Hey, hello, and welcome to the show. It's time for another John Park's workshop. It's me, John Park, and here I am in my workshop, and we are ready to go. So I know there's been some excitement in the world of streaming behemoth service providers. I think we're out on the Twitch today. I don't know if they're back to business as usual at the moment, but we had some resets of some encoding keys and things like that happen earlier, so I think we should be streaming on Twitch. Let me know over in the chat. Our chat, by the way, if you're wondering where it's at, it's generally right here on Discord. So if you head to the Adafruit Discord server and you can jump into the live broadcast chat channel, that's where a lot of people are talking about what's happening with the show and more. And then we also have over in YouTube, we've got some chat that I can keep my eye on. Hey, Gary and Dave and Shad K. Shad, for whom this music I was playing makes nervous. Well, I hope you're feeling better now that the music has stopped. Let's see, what else is up? Sounds like my mic is maybe slightly hot. I'm just going to turn that down a little bit. If I'm peaking at 0, I've noticed it's right on the edge later when I edit these videos. So thanks for C. Grover for keeping an eye on that, and hopefully we're down into a little more moderate range. What else? All right. Oh, that's interesting. Well, my computer is back up, and that could have been what caused it. We'll see if that clears up the buffer problem. Looks like it's running again. Yeah, the mic didn't want to be lowered. That's what happened. All right, it looks like, yeah, it's streaming, but it's giving some bitrate warnings. How's Twitch? I don't dare launch that. I'm going to leave that alone. I'll probably have to log back in anyway. Is anyone watching over on Twitch? Does anyone trust that anymore? It's terrifying to have the source code leaked. All right, I kick that back into gear, and we'll see in a moment when YouTube starts that back up. Thanks for putting up with this, these shenanigans. All right, hopefully that audio is back in sync now. And I'll tell you what, it really does feel like my service provider has swapped the Tuesday and Thursday service issues, because I used to have much more buffering on Tuesdays. Now it's happening on Thursdays, which is a pain in the neck. Oi. All right, well, I think that's probably good now. I'm hoping we're back in sync, and I'm going to plow ahead. I don't think it'll let me start the recording now that we're already up and running. So let's get on with it. Let's go through some stuff. First of all, we've got our job board. If you are looking for work, or if you are looking to hire someone, you might want to go and check out the Adafruit job board. It's at jobs.adafruit.com. That's what it looks like right there. I don't think we have any new positions as of last time, but you might want to look these over, or if you're logged in, you can check out people who are looking to get hired. And it's entirely free. You just need to log in, and we will never spam you or sell your email or any of that stuff. So these are all vetted. This goes through Phil and Lamore. They make sure that the positions that we're posting are legitimate seeming. So you won't get a flood of spammy stuff. That's our jobs board. And let's pull that off of there. What's next? Let's see. So on Tuesdays, I have my product pick show. And during that show, we generally have a large discount, 50% off in this case, on the product pick of the week. And the product pick this week was the Pi Ruler. And it's about a 15-20 minute show where I take a look at the product, do a little bit of a demo, take you on a tour of it, and then I like to go ahead and create a little recap, a little 1-minute recap. So I'm gonna I'm getting distracted by the error message coming from YouTube telling me that we are not streaming in a healthy way at the moment. Oh, drat. But you know what? I'm going to run that anyway, so here we go. It is the product pick of the week. It is the Pi Ruler. Oh wait, the Pi Ruler. It essentially has a Trinket M0 built right into it to run Arduino or run CircuitPython. And beyond just being a regular Trinket, it actually has 4 of the pins that are normally not broken out on the Trinket running to these 4 capacitive touchpads, as well as 4 bonus LEDs. You can see here on these capacitive touchpads, we have some suggested uses. This is a way to set up a little special keyboard that's really purpose-built for your engineering writing needs. Ohm character, the omega. We have the mu there for micro thingies, and we have pi. And then also this DigiKey logo here on the end will actually type in the URL for DigiKey's CircuitPython site and go there. That's the product pick of the week. It is the Pi Ruler. All right, so looks like we've got maybe an out of sync again. I'm just going to flick that little switch to turn off this. And we should be back in a few moments. I think I'm sending this already, but the buffering and all that will take a moment to catch up. And thanks for letting me know over in the over in the chat. Someone said I just said I'm just gonna, and then poof, went to nothing. So Lars has Eye of the Time Crystal. Yeah, choppy but in sync. I'll take it. All right, so next up, let's see. What I want to do is jump into the CircuitPython Parsec. You know what? What I'm going to do before I do that is I'm going to see if I can start my screen recording of this session in case we need to go to that to rebroadcast. So bear with me. I'm just going to set up a capture and turn on the record to disk. See if it likes that. See, Grover said the closed captioning wasn't delayed during the out of sync periods. Oy. All right, and good. Okay, so at least I'm recording now. Hopefully an in-sync version is going to the computer here so I can rebroadcast, either take over this full archive stream later, or at least just this CircuitPython Parsec, because that is what is coming up next. All right, let's get this set up here. Good. What I wanted to show for the CircuitPython Parsec today is how you can ask a CircuitPython microcontroller to tell you what its CPU temperature is. You'll notice some boards come with built-in sensors on the board for things like ambient or contact temperature, but most of the CPUs that we use actually have their own internal measurement for temperature so that you can do things like avoid overheating. So here's how we set it up. If you look here in my console, what I'm going to do is I'm going to type directly from the REPL to the board, and I'm going to import microcontroller. Now, if I just type in micro and hit tab, I'll get some tab completion. If I hit dot and hit tab, you'll see there are a few things that I can address here. I'm going to address the CPU. I'll hit tab again, and now it tells me I can ask for things like the frequency, the temperature, UID voltage. So I'm going to say temperature, and that's going to return to me. It's 30.7184, that's really precise, degrees Celsius. And now what I've done is I've actually set up some code that will, every couple of seconds, read the CPU temperature and print it out for me, and also do the conversion to Fahrenheit. So the way this works in code, you can see here, is that I'm importing time, so we can pause microcontroller. I'm also grabbing OS, just so at the beginning there it tells me the name of the board. Then I print os.uname.machine. That's what prints out the board name and the processor. And then in my main loop, I'm setting this variable called temp_Celsius to equal microcontroller.cpu.temperature. That's what asks the microcontroller's CPU to return its temperature. And then I also have this conversion in this variable called temp Fahrenheit, which is Celsius times 9 divided by 5 plus 32. And that gives me Fahrenheit. And then I print that with a little bit of formatting, so we get this nice readout down at the bottom, and then I pause for 2 seconds. And so that is how you can ask a microcontroller for its CPU temperature using CircuitPython. And that's your CircuitPython Parsec. All right, one question that I saw in our chat was, I wonder if you can warm it with your finger or cool it. I've wondered the same myself. So this has been hanging, if you look at it here, pretty steady at 29.3 to 6 degrees Celsius. So I'm going to put a finger right on top of the CPU, and we'll see if it, see it's going up 28.7. 28.5, 6. Yeah, I don't know that I'm having much of an impact on that. It's not running very hot, so it's probably not giving off a lot of heat that's getting adjusted by the ambient temperature. So you could probably get it to overheat, put it inside of an enclosure, but I'm not really impacting it that much. So you'll have more luck with an actual temperature sensor that's not inside the CPU package. All right. So let's move on then to the next thing. So it seems like we're stable now in our connection, which is good, knock wood. So what I'd like to do is do a little bit of a pick, a little bit of a, I'm going to turn this camera off and on over here, it just reset itself. Everything is rebelling. I think all my equipment is just slightly old now and is tired. I'll turn that back on before we go to the workbench later. So I wanted to do a game recommendation and a little bit of gameplay for you. I often like to do a gear review or a tool demo, but I've been playing this game that came out pretty recently that is relevant to the interests of me and anyone who's into logic puzzles as well as modular synthesis. So this when I saw this, it kind of combined a bunch of my interests. It's called the Signal State. And let me go to it over here. Okay, so the game actually does a really nice job of explaining to you, if you've never touched this kind of stuff, the basics of how a modular synthesizer works. And a lot of the puzzles are built around logic problems. And these are really relevant to the way a lot of things inside of synthesis work. I wanted to show this off. So it's reminiscent of software such as VCVRack, which is a virtual modular software synth that you've seen me use before. And the puzzle in this case, my image is blocking it there, but it says circuit breaker. Out 1, so this module has an output called out 1, receives source 1, which is this over here. Receives that signal, but it's going to be increased by 5 volts. And out 2 receives source 1 signal with its intensity halved. So if we don't plug anything in right now, and I just sort of step through the time, one frame at a time, you can see that at the first frame it had 0 volts coming out of source 1. Now it has 2 volts coming out of it. 4, 6. So it seems like the voltage coming out, and you can see it plotted down here, that's actually telling you, to help you with the puzzle, what's going to be coming out of source 1. So I'll hit stop there. So what I can do now is take a little patch cable and connect this source 1 to a splitter. So this allows me to get multiple copies of that signal because I'm doing, in this case, a couple things with it. And this is, again, something that you face in real modular synthesis, is needing to split signals out with something often called a buffered multiple. Right now, if I plug the outs from the splitter to the system output, it's going to fail because I haven't done any of the things they've asked me to. But the thing is, we've got a little tray with modules in here, and they keep it pretty minimal at first so you don't get overwhelmed. It kind of introduces them with each puzzle at first. And the ones that I care about here, there's one called bias. I'm going to bring one of those in. And it says bias takes an input and shifts it by a constant offset value. If there's no input, it outputs the offset value that you dial in here. So that means I can do this first requirement, which is I'm going to increase whatever's coming out of here by 5 volts. So I'll take one copy of that output, bring it into this little bias module, and then I'm going to crank the knob up to 5. So that's just adding 5 volts to whatever is coming in. And then I'm going to send that output to output 1. The other one we care about here is this attenuator. It's actually kind of an attenuverter. It allows us to attenuate sort of like a potentiometer does. We can decrease the voltage that's coming into it before it goes out. And we can actually create an inverse version of that by going left with the knob. But in this case, we just want half the voltage, so we're going to put this through the attenuator set to 50%. So I'm going to take a copy of the output, go into the input here. By the way, you can make some more sense of what you're doing with colored patch cables. So I'm going to use red patch cables for this second side of things, just to keep things a little more visually clear. And so now if I step through the solution, you'll see that it's happy, first of all, down here at the bottom. It's not giving me red, it's giving me the happy yellow line colors. And I am getting a 0 voltage on first step, which gets 5 added to it, and it also gets divided by 2, which is still 0. Next step, we can see we're going out to becomes 7 by adding 5 to it. And oh, I screwed up my attenuator. Let's get that back up to 50%. I never actually changed it, did I? Let me hit stop on playback. And you can type in numbers in here too. You don't have to use the dial, which is nice when you're trying to be precise with it. Okay, so if we try that again, now we're successful on step 2 because it's giving me the 7 for output 1, and it's giving me half of 2 volts or 1 volt for the next one. And then we can just hit play and it'll run through it, and you should be able to hear. It's lagging a little bit just because so much is happening on this computer right now. It's probably not happy. And you get the little tally of your score at the end, which is also kind of fun. My favorite part is just solving the puzzles, but you also have some of the gameplay built around the efficiency with which you do it, the length of the cables you use, how many modules you use, how much space you take in your rack. So there's a few different metrics there for the score, but kind of the most fun part for me is coming up with solutions using these modules for your puzzle, solving it, and then they introduce more modules as you go. And there's also a nice little storyline happening about sort of a post-apocalyptic farm that you are rebuilding one piece of equipment at a time by doing modular synth stuff. So come on. It's called the Signal State. There's a demo that you can get for free, which has, I think, 10 levels in it. I bought the full thing, which might have been 10 or 20 bucks, I think. I don't think it was that much. So I'm not affiliated with them. I'm not getting any kickbacks from them. I just thought it was really cool and wanted to share it. So go check out the Signal State. And it's on Steam. It might exist elsewhere, but I'm playing it via Steam. And I'm playing it on a Mac. You can get it on Mac and Windows. And I think some people are having some success playing it on Linux with the sort of Windows gaming Steam layer, which I think is called Proton, if I'm not mistaken. So go check that out. Let's see. Oh, someone's telling me that I've got a spelling mistake in Celsius in my code there for the CircuitPython Parsec. Whoops. At least I've stopped calling it centigrade because you can tell my age when I was a kid and we talked about the other temperature system. They called it centigrade a lot of the time, and I know now that they actually are different. Yeah, Proton. Proton is the name of that gaming layer. All right, so next thing I want to do, I'm gonna quit that game just to see if it gives me back some precious CPU cycles. That's kind of a miracle that played. Pulling games into the Wirecast there is something I've had some issues with before, but it worked. Okay, so for project build today, I wanted to show off this cool little 5-volt ring light that we just started carrying in the store, and I got the bare one, which looks like this. That is the front of the light. It is a cob or circuit on board, meaning the LED elements are essentially soldered directly to the PCB, not in their own packages first, so it keeps it small, keeps it less expensive. Here's what it looks like on the back side. So there's not much there other than a resistor and some pads to solder on for voltage. And here's a nice picture of one glowing. So these are a cool white, so a little bit bluish. I don't know, they probably make warm and neutral. Maybe we'll carry those too. This is the one we have right now. And this is a 70 millimeter diameter ring. Let me grab the one I have. I just have one, so hopefully I don't blow it up during the show here today. And it's got a little bit of a diffusing coating on top as well. These, I don't know if these also fluoresce. They may, just to help with some of the goal of reducing the visible dots. So that's one of the goals of these, is to try to present it as kind of a cool continuous ring of light. And these run off of 5 volts, which is really cool because we've had some in the past that run, I think, on 9 volt. These run off of 5. You can run them right off of USB. In fact, we sell a version that has a USB cable with the on-off switch for power directly connected to it. So that's super easy plug and play. So if you're looking for something to simply add to a costume, this is great. If you're looking to add a little bit of lighting to a photography rig, for example, you'll notice this is a great size to fit around the big camera cluster on your, let me get this window out of the way here. On your modern phone, you get this really big camera cluster. So if you wanted to just tack that on there with some blue tack or something and have a light, you might be able to power it if you're cleverly arranging like the cable for camera connection on iOS to a USB. You might be able to even just power it off of there. But the thing is, you can plug it right into a USB power pack, so you can get lots and lots of power and not mess with your phone. The version that I'm going to use, which is this bare one, we just need to solder a couple wires onto there and then give it anywhere actually from about 3.3 to 5 volts. So that's one of the nice things, is that we have some range to work with. So let me jump over to the workbench. I got to get this camera working again. Come on, camera. It's not hot today, so I'm surprised that it's shutting itself off, which is usually an overheating thing. Unless I've somehow kicked the power cable and it's trying to run off a battery, but I don't think so. Let me see here. I'll focus that. Lars was helping me with focusing earlier, actually. It's a nice way to figure out if you're in focus or not. Oh, and look at that. My little show logo disappeared for who knows what reason. That's bizarre. That's still there. That has gone away. Huh. Weird things are afoot. I can't explain that one. It just disappeared on its own. Well, we'll get rid of that little black box. So let's jump to the main cam and down shooter here. And hey, look, there's Woody. So I don't mean for this just to be Scary Puppet Day. I promise. Oh, by the way, I'm just noticing someone asked in the chat on YouTube. The Signal Source is the name of that game. All right, so let's jump over there, and I've got my chat up on the iPad here, so I should be able to tell if you have any questions or if you're noticing any issues with the stream. Set that there. So let's test this out first, and then I'm going to show you how to drive it using the PropMaker FeatherWing, which is a really good option for something like this. Since the PropMaker FeatherWing has PWM outputs with, I think, pretty high current available on 3 pins, meant for doing things like sort of analog LEDs, like big 1 watt and 3 watt LED packages. You can just plug one of these rings, or up to 3 of them, into your PropMaker, and then have a nice way to connect it and do some PWM for dimming, pulse width modulation for dimming, which is really, really nice. So first of all, let me see if this is connected to my little camera switcher. Let me replug that and make sure that it's accepting that signal so I can change views from over here. I'm going to test it over here first. 1, 2, 3, 1. There, that'll work. And that'll give me an opportunity to focus that in a little closer. Like that. Okay, so first I just wanted to get 5 volts on this to test it out, and I wasn't sure what I was going to be soldering to the power connectors there, so I've just sort of rigged up a goofy little wall wart 5 volts to one of our little DC power plugs that has an on-off switch, and then I've plugged, without soldering, I've just plugged in a couple of jumper cables, put a zip tie on there so they don't move around and short. And that's my test jig there for that. You could also use a benchtop supply. So I'm going to hold this up a little bit so that we can see the glow when it lights. But I need to be able to see it from back here. So let me put the negative is marked with a little minus sign. And that's about it. So you got to pay attention to that. And now I will turn on this little power right here, and I double checked the voltage was correct, so now we can do a little boop, and there you see we get a really nice bright light there. Super, and that's facing away, so you can imagine, which we'll see in a minute once I get it hooked up properly, how bright that is to camera. So for running this with the PropMaker, what I've got is I set up a little feather tripler here. It's just what I had handy. You could do this with a doubler. You could stack some a feather in the FeatherWing if you have them arranged that way. This is a Feather RP2040. It's running CircuitPython. This is the PropMaker FeatherWing, and the PropMaker FeatherWing, let's see, can I get a little closer even? That's as close as I can get. So the PropMaker FeatherWing has these outs here, which are a common anode, and then there's a different ground for blue, green, red. So I've picked just the blue one, but that could be anything, right? That's just a PWM output. That it's PWMing this pin as a negative ground pin, I believe, and this is going to be a constant source, I think, of 3 volts on that. We can double check that. No, I think that's 5 volts actually. It's designed for these bright LEDs. So what I'm going to do, you can see I've actually put a couple of these little clips that go into through-hole holes that allow us to just attach leads when we're testing stuff. That was actually, we'll do that next. We'll kind of show the evolution of how I'm working on this. So let's grab a little multimeter and double check the direction of our, I marked this one black here so I knew it was ground, but this is the sort of triple checking that we need to do to make sure we don't burn stuff out. So I'm gonna get power to that feather board, and I'll run this over here. So we'll take a look at the code in a little bit, but what the code is doing is just sending a pulse width modulation of the duty cycle to this ground pin and stepping it up and then down in its duty cycle so that it lights up sort of dim to bright and bright to dim to off. So I'm using this white alligator clip here as a ground, so I'll just hook that to this little clip connector, and this red will be my power, and I can double check on my multimeter here. Multimeter is pretty slow. It's not going to pick up the PWMing that well, but we should see this is 5. Yeah, it's just not, it's going too fast for it to tell, but it's basically going from 5 to 0 back to 5, or a little more than 5, in fact. So let's get that out of there now, and then I'll clip these to the light. So this is, get one tooth of that on there. You gotta be careful, you'll short stuff out with these. There we go. I think I am wiggling, there we go. Okay, so this should get brighter and dimmer, brighter and dimmer. Excellent. I'm not gonna dare to turn them towards camera yet, just because I'll short things and make stuff fall apart if I try that. So let's put it together. So I'm gonna take the power off of this feather, and it's not a bad idea to unplug it from the wall and the board, just to really be sure of what you're doing. So that's disconnected, and now this little ring, what I'm gonna do is I'm gonna use a JST cable that we have, these little, I forget which model of JST these are, but they're a locking polarized connector, so you can't mess up your positives and negatives. The only trick with these is that the wires themselves are not marked, so you do want to kind of go and make a mark on them, or put on some heat shrink tubing before you use them, so you keep everything straight. So what I'll do is I'll get a little bit of maybe some red heat shrink, so that I can put that on the positive wire and know that I'm connecting apples to apples on there. So let me zoom this out just a little here. So I'll go into the box of heat shrink. I'll get some of this real skinny stuff right here. Just cut off a little piece like that. That. And now it's just pick one. So I'm gonna have that be the positive side, and I'll go ahead and heat shrink that on with my hot air gun, so it stays nice and snug on there. And then I want to just trace that. That's that wire on that side. I'll just flatten that wire with my fingers as I go until I get to the end here. And then if you're being real paranoid, you can also use your multimeter to check that before really committing. So we'll just trim a little heat shrink off of that side, or insulation off that side. Let's take our multimeter in continuity mode. This will beep when we have continuity. And so it should be that to that. So you can hear that. That's telling me, yeah, you've picked the right one. I'm keeping an eye on it. I'm throwing heat shrink on. And there you go. You can wing this stuff, but at some point I've learned it does end up biting you. And you burn something out and lose a bunch of time and energy and maybe money. Now, if you're using if you're going to use these rings for something like a wearable cosplay thing, you might want to use some of the nice silicone wire, which is really soft and flexy. This is this sort of normal PVC covered stuff, which is not as neat for hiding under things. So next thing we'll do is, I think I'll take my cable end, the short end of this, and solder that to the PropMaker. So it just has a little tail coming off of it, and then I'll put the longer wire on this. You could trim that wire if you needed to as well. So let's take that out from there. I'm gonna heat up this soldering iron if I can extract it from away from my iPad. Let's see. I'm using one of these snazzy little pencil irons. It works pretty well for this. So we'll let that heat up. Grab a little solder station. I've got pretty good ventilation. I've got the AC fan blowing on now. So I'm going to remove that little clippy that I had there. And these are nice because they actually have a little strain relief, so you can come in from the top or the bottom, and then through these little mounting hole kind of holes, drill holes, and then solder to the other side, and that gives you a nice bit of strain relief. So let's see, I think I'll have these coming up from the top. So I'm going to go in like so, flip it around, and then those will dive into their respective holes. So this one says V plus on it right there, so I'm going to bend that over and into V plus. Pull that back like that. And then I can solder that from the top side there. Let's grab low volt. Why is this saying low volt? Hey, that's no good. That's a first. Anyone seen one of these say low volt before? It's a good supply that it's plugged into. Weird. These heat up fast, though. That's good. Okay, so let's get in there. This is a tight fit for this iron tip. Okay, it looks like I got it. Shoo. And now other side is going to go into that one marked blue. So I'll pull out the other clip that I had there. Oh, no, I didn't. I missed. That was out when I soldered. I may need to strip that a little longer. I'm going to actually try to solder that in from the bottom side since we have so much more clearance. Might have been a better idea to start with. Hold on. I should get some helping hands involved here. And I should get some needle nose pliers to get that wire where I need it. This is not what I thought was going to be the challenging part of this demo. Just trying to get that soldered. There we go. Yeah, that'll do it. Let me refocus. And now we have lots of room. That's much better than the other side. There was a little capacitor right next to where I was trying to solder. Made it a little tricky. So this one here, take that out for a second. I'm going to fold that over. This would also be a little easier if you didn't go for this strain relief option, but I think it's a nice one with props to have it routed through that hole there. Sorry, I'm sure you can't see that very well. So close. There we go. Yeah, someone asked if I can check the resistance of that ring resistor. I will in 1 second. Lamore mentioned that you could change that resistor out if you wanted to use a different voltage on it. Oh, did this cool down again? No, it's hot. All right, so we've got that soldered now to the board. I'll probably verify those connections before we plug it in, but let's see with this. Presuming that we can check this resistor with it in circuit. Sometimes you can with things, sometimes you can't. Let's see. Seven ohms? No. Yeah, 6.6 ohms it's claiming, for what that's worth. I don't know if that's accurate or not with it in circuit, is it? So now what we'll do is connect these to the ring. And you might, depending on how you're using this in a prop or costume type of setting, you could get a little fancier with your wiring, such as cutting these at different lengths. Let me drop the camera here. So that you can come in from the side or something. I'll just go right underneath it like this, and we'll hold that still-ish while we work. These are not tinned, so I will go ahead and tin those first. Make it a little easier, and I'll tin these as well. And if you're not familiar with that term, it just means putting a little solder on something before you solder it to another thing. And it just makes it a little easier to make these connections. Okay, so that's a little solder on those guys, and then I can clip my wire to something for a second, and I'll tin these. And now that means, let's see, I've got these flipped, so the negative, you can still see a little bit the minus sign on that one. So let's do the positive one first. Inside here. And then this ground. Okay. And I think we're good. Looks like that should be negative, that's positive, it's red, positive. All right, let's go for it. So let me zoom some stuff out a little bit. Let's see what's getting plugged into what. So now our prop maker is ready to go. You can also, I'm just PWMing this, but you can also set up a lot of interesting things here with I believe there's a microphone on it or an input for one. There's accelerometer. You can do tap detection with that accelerometer. You could add a switch or a button. So there's a lot of ways you could control this. You could use an analog input to make a sort of PWM-based dimmer. So now I've got this. I'm going to unplug that soldering iron because I need that spot for the power. So this is my USB-C power. Whoops. Yes, it's time to clean the workbench. And I'll go ahead and plug it in. Let's hope for the best. Hey, it works. And now you can see we get this nice pulsing dimming effect. Point that at the camera. I believe I'm going to half brightness, so the duty cycle I have set to 37,000 or something like that instead of 65,000. So just to prevent from blinding myself, mostly. And that'll keep this a little cooler too, I think, by not working it quite so hard. But this is now a really nice little light source that you can do some sort of cool, creepy effects with. That's why I had Woody in the box here. Because if you're doing, let's say, some creepy uplighting for him. Come on, how cool is that? And you can imagine you can get your lens right up on there on something if you're trying to take a picture of it. Let's, you wouldn't want the dimming effect, but you can see now I've got this nice ring light. Doesn't interfere with anything. You can see it changing its brightness in there. Oh, it can't find it. Oh, now it's bright enough. But I like just the fact that this thing is so small, so light. You can just add it right inside of a prop or a model lighting situation. I guess we can be a little kinder to him and light him from the front a little better. So that is one way to get this this little light doing some dimming for you using PWM and CircuitPython. Let's bring this over to the rig over here, and I can plug it in, and we can take a look at that code now. And let's switch to this view. I'm going to set this in our little down shooter here. And let me plug that in, and then we can take a look at it. In action. So let's actually go to this little setup here. And I'm going to go to the code. So let's, I'm going to open it off of the board actually, because that is going to allow us to make adjustments and save it right to the board. That's what I started from, a simple rainbow example for a 3-watt LED from the guide on the PropMaker, but then I've adjusted that. Let's focus that camera a little better. Okay. Ooh, that's bright. Now it's pointing right at me. So let's, oops, let's close that. So here's how it works inside of CircuitPython running on the PropMaker FeatherWing. I'm bringing in time, PWM I/O, board, pin definitions, and digital I/O. So digital I/O is just enabling the power pin. So it's just setting that pin high. It's pin 10, and that's the one that the positive side, the red side here, is plugged into. So that means that that pin is always high, and then what we're actually PWMing is the ground pin. And so the ground pin in this case we're using is that one marked blue, but you have that red, green, and blue, and that's how you can mix colors on those 3-color non-addressable, non-NeoPixel type of LEDs. So then I set up that pin, I called the pin light ring. I set up that pin, it's actually pin D13, as a PWM, pulse width modulation output. And if you're not familiar with pulse width modulation, it essentially is a way of sending square waves that are at a low, a zero, or a high, and you can change how quickly you do that to approximate other voltages. So it's just an averaging of these square waves that makes it seem like an analog voltage, even though it's not. So I'm setting that on pin D13. I have a duty cycle of 0, and then I have a frequency of 20,000. So duty cycle means it's basically off. We're setting up a variable here for how many steps of brightness to go with. We're going with 10. And we're starting that off, that duty cycle, at 0. And we're ending it at this 32,767. And so that's what takes it all the way up to full brightness, opening up that ground pin. Then in our main loop, all we do is, I have this loop that brings it up. So it says for the PWM, that's just a variable, could be I. For PWM in the range, the start PWM, which is 0, the end PWM, which is 32,767, and then the number of steps, it's going to iterate through that many times, 10 times, and increase it each time to get to that maximum. I have a little bit of a pause in there so it doesn't happen super quickly. We'll take a look at that in a second, what happens if you pull that out. And then after it gets to full brightness, we drop it back down by doing basically the same thing in reverse. We start with that end number, 32,000. We're going to end at the 0, which is our start number. And then we're going to go in increments of subtracting the steps, 0 minus the steps, and that's what takes us from 10 back down to 0. The light ring duty cycle in both those cases is just set to whatever that value is that's increasing or decreasing. So if we take a look at, just get rid of the pause there, now it's going to do it as fast as the microcontroller can. So let's hit save. And it's blinking really fast. It's actually faster than the frame rate of this broadcast, so you're just going to see some funny business going on. You can also make this really slow. Let's set this up to 0.2. And now it's just very, very, it takes a while because it's going through these 10 steps to get to full brightness. And you could make that as slow as or as fast as you want. Of course, there's a lot more you can do with it. One nice effect too is to not drop back down, but just flick back down to 0. So if we just comment this code out right here, and I'll set this back to so now it ramps up to full brightness and then goes to black, goes up to full brightness and back into black. So I think that's a nice looking effect as well. Let's see. Suggestion on a value, it's really bright. You could live with it being less bright. Are you talking about my duty cycle, or are you talking about the resistors still? I'm not sure. Could you use PWM to reduce the power? If I understand the question, yeah. So my end PWM here, that's as bright as it's going to get. So it's 30,000. If I set this, say, to 10,000, and hit save, you're going to see it will get not quite so bright. In fact, what I'll do right now is let me comment all of this out, and I will just set a duty cycle value. So let's go to 5,000. Hit save. Okay, that's not enough. Let's go to 10,000. Why is it just blinking? Something's wrong. Why is that just blinking? That shouldn't happen. 30,000, how about? Oh, does it have to be a real proper number? It might. No, I don't think it does, actually. Let me see. Yeah, I don't know why it's just flickering. What am I doing wrong there? I am not sure what's up with that. Someone can probably tell me in the chat. Oh yeah, you're talking about resistors on the USB one. Let's see. So if I set, let me see, if I tell it to get there in one step, and I tell it to get to 5,000, will we see, in fact, a dim? Yeah, I don't know what was up. Okay, so that's quite a bit dimmer, especially for me here in person. It's a little brighter on that camera. I don't know what was up with what I was trying to do. Let's set it to 1,000. So again, kind of dim. It is still, yeah, that's quite a bit dimmer. Let's see how low we can go. Yeah, it's barely, you can maybe see some illumination right there. What if I take out this? There we go. Now it's steady. So let's bring that back up. How about 500? So it's a nice bit brighter. Double that. So you can see you could feed in something like a potentiometer or an encoder, and then turn those values that you input into a PWM value that allow you to do dimming. And that's how a lot of modern lighting works. So if you look at like ring lights that you use for putting them behind your computer to do Zoom calls and stuff, I suspect a lot of those are using a very, very simple circuit to do like a 555 timer style circuit to do a pulse width modulation to a big gang of LEDs that are arrayed in a ring. So that is it. That's the ring light in action. I just wanted to give it a little more control than just like the USB version is cool, but that's just on or off. You can wire it up to your own power source, or by introducing the PropMaker FeatherWing in here, we had a really great way to do a PWM brightness to it on a nice board. This can be all running off of a battery as well. If we, let me see if I can undo a bunch of times and just get back to where it was. Almost. There we go. So now I'll grab a little LiPo battery and plug that into our feather board. And I can now unplug from the USB power. And now I've got my nice little portable thing, and this can be doing whatever you want. Have buttons attached to it, knobs, dials, use some of the built-in accelerometer functions, and then you'll have your cool prop light ring for whatever nefarious needs you have. All right, I think that's going to do it. So let me know in the chat if you got any thoughts or questions on that. Otherwise, we're going to wrap it up. People are thinking Stargate. Yes. Any other questions? Thoughts? Use heat insulating adhesive foam between the PCB and a sink. Oh yeah, so if you wanted to put a heat sink on it. Yeah, this one is not even warm from what I was just doing to it. Maybe it just cooled off real quick, but let's, if we plug that in. Doing this, I don't feel any warmth on this at all, which is great. All right, so let me jump back here, and hey, it looks like we made it. It seems like we stayed in sync with audio. Sorry about the rocky beginning. Maybe that's just the way it goes these days with the internet, the way it's working for me. I don't know. Woody says thank you for stopping by. So does Lars, but he's off camera now. And I'm going to call it right there at 2:04. That was a long one. I will see you next week. I'll be back on Tuesday with another product pick of the week and a workshop show on Thursday. So thanks everyone, and have fun out there. Bye-bye.